4 and 5.
Question number 4 and 5. Hmm. This is the circuit and the question is voltage gain. Hmm. And the value of okay, so this is the question. Hmm. I think my screen is visible to you all.
Yes, sir, it is visible.
So what we do, we have to find out the V naught 2 upon Vi. So first of all, what is the formula for what is the value of V naught 2 upon Vi? Yes, what is the value of V naught 2 upon Vi? That is SRC2 upon 1 plus SRC2 plus S square R square C1 C2. This is the formula. Any doubt in that one? You can refer the videos also for that particularly formula. Okay. Now we calculate the magnitude of that one. So V naught 2 upon Vi mode. So how we calculate the mode? So S is j omega. So we calculate the mode in the numerator and denominator part. Okay. So in the numerator part, it is the omega r c2 whole square plus that is the imaginary component and real component is 0 and root of this one upon if I break this one, so s is j omega, so s square is minus omega square. So the real component is 1 minus omega square r square c1 c2. The real component square plus imaginary component is omega r c2 and root of this one. Okay, so V naught 2 upon Vi mode that is equal to if I break this because of the zero, this square and square root will be cancelled out. So omega r c2 divided by 1 minus omega square r square c1 c2 whole square plus omega r c2 whole square. Now put the values. So omega is 2 omega, so 2 into 10 raised to power 6 multiply by 2 pi multiply by r is 20 into 10 raised to power 3 multiply by c2 is 10 into 10 raised to power minus 9 divided by 1 minus omega square. So omega square is 4 pi square into 4 into 10 raised to the power 12 into r square 400 into 10 raised to the power 6 into C1 is 0.5 and this is a 10. So if I multiply, so it becomes 5 into 10 raised to the power. This is minus 9 and minus 6 minus 15. The whole square plus again the same value omega RC2. So I just multiply. So 6 and 3, 9 and 9 cancel out. So it is a 2 pi, 4 pi into 20 into 10. So 200, 200 into 4, 800 pi. The square of this one and root of this one. Okay, if I solve the numerator, so 9, 3, 6 will be cancelled out. So it is a 200 and 800 pi divided by 800 pi square plus. Now if I solve this one, so it is a 12 or 6, 18 and it become minus 15. So it is a 3. So it becomes a 16, 64, 64 5 are 320 pi square into 10 raised to power 5 square and root of this one. Okay. Now this term is very less than this one, so I can basically neglect this term. A square and square root will be cancelled out. So it is 800 pi divided by 320 pi square into 10 raised to power 5. So pi and pi cancel out. So 100 divided by 40 pi into 10 raised to power 5. That is a 1 divided by 40 pi into 10 raised to power 3. I think that is the value you are getting. Yes. So what is the value you are getting from that one? Now clear any doubt?
No, sir.
Okay. Now fifth one. If you see in the figure, what is the relation between V naught 1 and V naught 2? V naught 2 is nothing but minus of V naught 1. Okay, minus R by R into V naught 1. So minus R by R will be cancelled out, so minus V naught 1. So that means for the V naught 1 upon Vi, we are getting the same formula as SRC2 upon 1 plus SRC2 plus S square R square C1 C2. Okay. Now again we take the magnitude. Sorry, with minus sign. If we are taking the magnitude V naught 1 upon Vi, so it is again omega R C2 upon omega R C2 square plus 1 minus omega square R square C1 C2 whole square. Okay. Now put the value of omega as 200 hertz. Two pi into 200 hertz. 200 into R 20 into 10 raised to power 3 into C 1 into 10 raised to power minus 9 divided by again same term. So if you see here, so it is a 10 raised to power minus 6, 2, 2 and 3 zeros, so it become a 10 raised to power minus 3. So it is a 8 pi into 10 raised to power minus 3 divided by that component. Okay. Any doubt?
No, sir.
You know how we solve the transfer function? Now in the week 7, basically we discuss about the non-ideal op-amp. Okay, so basically in the case of non-ideal op-amp, generally we take three things. One is their input resistance is not a infinite quantity. Second, their output resistance not be a zero. And third, their gain is not a constant parameter. That means it is dependent on frequency. Okay. So yeah. Now if we are comparing with the ideal op-amp and the non-ideal op-amp, so we know that R equal to infinity, that is not achievable. Okay. So in the case of ideal op-amp, we generally consider the input resistance RIN is should be infinite. It should be infinite, but the high omega is also considerable. That means my Rn should be in mega ohm. Similarly, for the non-ideal op-amp, what should we consider the Rn is in mega ohm. Second scenario, R out is 0. Again, that is not achievable. So R out is in ohm, 100 ohm, 200 ohm. That will be considered. But ideal op-amp is frequency independent. That means gain is constant, response is constant, gain bandwidth is gain multiplied by bandwidth product. Your gain bandwidth product is infinite. Okay, what is the gain bandwidth product? The multiplication of gain and the multiplication of the bandwidth. Okay. And fourth thing is gain is also very high. Whereas for the case of non-ideal op-amp, the gain is not a constant. Okay. If gain is not constant, the response is dependent on frequency. Okay. Gain bandwidth product is finite. Okay. And gain is that is dependent on this type of operation amplifier you are using. Okay, so week 7 is completely on the non-ideality or basically non-ideal op-amp. So in this particularly week 7, if we are discussing that the AS is either 1000 upon S or 10,000 upon S or 100 upon S or 500 upon S. So basically S factor is there, and what is S? S is j omega. So that means this particularly gain is dependent on frequency. If we increase the frequency, automatically gain will be reducing. Okay. Clear? Any doubt?
No, sir.
Okay. Now, if the gain is this one, so we can say that the transfer function of this particularly is a naught upon 1 plus s upon omega naught. Okay, what is the meaning of 1 upon s plus j omega naught? Or s plus omega naught is this omega naught is nothing but a bandwidth. Okay, so what we are doing, we are calculating the transfer function, and with respect to transfer function, we are calculating the omega naught. So if any particularly is given, like for example, I am giving a question. If this is a question, now how we solve this type of question is that previously what we assumed that the input voltage is equal to the positive terminal voltage is equal to the negative terminal voltage. Why? Because we are taking that my op-amp is a ideal op-amp. So if ideal op-amp, so in the case of ideal op-amp, generally the resistance value is high, so that means no current will be going inside that one. But if my operation amplifier is non-ideal, so we are taking that V out is nothing but the gain multiply with the positive terminal voltage minus negative terminal voltage. Okay, for a non-ideal. If it is a ideal, we know that V naught is A times V plus minus of V minus, that becomes 0. That becomes 0. Why? Because in the case of ideal, V positive voltage is equal to V negative voltage. in ideal. In the case of V and non-ideal, V plus is not equal to V minus non-ideal. Clear? So with change of the ideal to the non-ideal of them, everything will be changed. Wait a minute. Hmm. In the week 7, generally we discuss. Yeah. Just wait a minute. Yes. So, we know that the output upon input V naught upon Vi is nothing but A naught upon 1 plus S upon omega naught, where omega naught is the bandwidth, A naught is gain, or we can say the finite DC gain also. Omega is the frequency. Okay. So as we put the S is equal to j omega, so A naught upon 1 plus j omega upon omega naught. That is V naught upon Vi. If I take the V naught upon Vi mode, so that is A naught upon root of 1 plus omega upon omega naught square. Okay. So if omega is increases, if this is the omega, if omega is 0, so what is the gain? A naught. Okay. So that's why it is called the DC gain, finite DC gain. Why? Because the frequency is 0, then the magnitude of V naught upon V9 is called the DC. There is no frequency, so the particularly value is called the DC. Okay, so finite DC gain. Now if I increase the omega, so when I increase the omega, V naught upon Vi will be decreasing. Okay, V naught upon Vi will be decreasing. When omega is equal to omega naught, sorry, So that is equal to a naught upon root of 1 plus 1. That is a naught upon root 2. So that particularly frequency is called the omega naught. Okay. What is bandwidth? So from this particular range to this one is called the bandwidth. Or you can say the omega naught as a cutoff frequency. Okay. And for the low pass filter, this omega naught is also equal to the bandwidth. Why? Because bandwidth is what? Higher frequency minus lower frequency. And for the low pass filter, the lower frequency is 0. So 0 minus higher frequency. That is bandwidth. And both will be the omega naught. Both will be the omega naught. So bandwidth, omega naught, bandwidth is equal to omega naught minus 0. So bandwidth is also omega naught. So either you say the bandwidth or you say the cutoff frequency. Okay. Now I think you are aware about the Bode plot also. Have you idea about the Bode plot? Yes, I think EC covered the Bode plot part now. So you have the idea about Bode plot? Yes or no? Okay. So basically what is the Bode plot? Bode plot is nothing but a frequency response of a first order or second order system. So we know that A naught upon 1 plus S upon omega naught. So this is a first order system. First order system. Why we call it as a first order system? Because if you see only one pole is available, or we can say the highest power of S basically represent the order. Okay, highest power of S basically represent the order of system. Okay, now if any particularly thing will be represented in the form of N upon P, so N is called the numerator, or it represent the zeros of system. Okay, and P denominator, and it basically define the poles of the system. Okay, so highest power of S also represent the number of poles or zeros. Either the highest power of S in the numerator, so it define the number of zeros. If highest power of S will be available in the denominator, it shows the number of poles. Basically, number of poles or zeros define the order of system. So, if you draw the Bode plot, so that is your omega. If you see here, so 1 plus s upon omega naught is equal to 0. So that define the position of pole. So position of pole is what? S. So S is nothing but omega naught. Okay. So we can say one pole is available at a omega naught location. One pole is available as a omega naught location. Clear? Now, before available of this port, we have a constant gain A naught. And after that pole, we have a slope n times 20 dB per decade. Or we can say the plus minus n. Plus represent zeros and minus represent poles. Okay, n represent order of system. So we can see that only pole is available and first order. Okay, and only pole is available and first order. So because of poles, the minus, and because of the first order, n value is 1. So it is a minus 20 dB per decade. So this slope is downward because it is a negative. If any zeros is available, so our slope will be the positive. Again plus minus n 20 dB per decade. If zeros and if okay. The magnitude will be represented in the dB. So this value A naught is not exactly A naught. This is the 20 log 10 of, okay. And where this line will be cut, we can say the magnitude is 0 dB. Magnitude is 0 dB. So 20 log A naught is equal to 0. So we can say A naught is 1 or unity gain. Okay. If omega is greater than omega naught, so the response V naught upon Vi is A naught 1 plus j omega upon omega naught. Omega is greater than omega naught, so omega upon omega naught is greater than 1. So I can replace that one a naught upon, basically this one is very less. So we can neglect, so that is the j omega upon omega naught. So that is a naught omega naught upon j of omega. Okay, and this v naught upon vi is what? It is 1. So that means a naught omega naught upon omega mod is 1. So that means omega is what? A naught omega naught. Okay, so that means this cutting point is what? A naught omega. Because at omega is equal to a naught omega naught, magnitude is 1. Okay, and we already see that this particularly point is called the unity gain. So gain is 1. So that means omega is equal to a naught omega naught. So this particularly point is also called the a naught omega. Okay, if we are seeing this particularly the bandwidth, so that bandwidth is omega naught. If we completely watch this bandwidth, so that is a naught omega. Okay, now we already see that if omega is equal to omega naught, v naught upon vi is what? 1 upon root 2. So that means it is called the 3 dB bandwidth. Okay, and when omega is equal to a naught omega naught, that means v naught upon vi mod is 1, and it is called the unity gain bandwidth. So two different bandwidths will be defined here. Okay, and if you see the unity gain bandwidth, so the value of unity gain bandwidth is what? A naught omega naught. Where a naught is what? Gain, and omega naught is 3 dB bandwidth. So this a naught omega naught is also called the gain multiply with bandwidth, or it is also called the gain bandwidth product. Okay, so unity gain bandwidth is also called the gain bandwidth product. Any doubt? That particularly gain bandwidth product is very important parameter. Why it is important parameter? Because it will be decide that which operation amplifier we are using for a particular application. Like for example, I have a gain bandwidth product of 1 megahertz. Gain bandwidth product. That means if I am using the operation amplifier up to the 1 megahertz, it will be providing me the V out upon V in as a 1. Okay. If I am using up to the 500 kilohertz, it will provide me the 2. If we are talking about the 250 kilohertz, so we are having the gain of 4. Okay, so now you can see the gain is dependent on frequency. For every op amp, gain bandwidth product GBP is constant. If you increase the gain, bandwidth reduces. If you increase the bandwidth, gain reduces. So the product will be remaining constant. Okay. Now take an example is that this is Vi, V naught, R, 10R. In the second case, R, 10R, Vi, 1000 by S. Okay. We are considering this is the ideal op amp. This is non-ideal op amp. Can you calculate the transfer function? Yes, can you calculate the transfer function of that one? Yes, what is the transfer function in non-ideal op amp? So for the ideal op amp, we know that it is a non-inverting amplifier. If it is a grounded, so voltage at this point is zero. Voltage at this point is also zero because of a virtual ground concept. Okay. So the V out upon V in is equal to minus RF by RI. That is minus 10 by 10 R by R. That is minus 10. But in the case of non-ideal op amp, we can't say that both voltage will be same. This voltage is zero, but this voltage is Vx. Okay. So what is the Vx? So Vi minus Vx by R is equal to Vx minus V naught by 10R. So if I calculate the Vi, so Vi by R plus V naught by 10R is equal to Vx 1 plus 10R plus 1 by R. Okay, so take the LCM. So we are taking the LCM 10R. So it is at 1 plus 10 Vx is equal to Vi by R plus V naught by 10R. And Vx is 10R by 11 Vi by R plus V naught by 10R. So if we simplify that one, so 10 Vi by 11 plus V naught by 11. This is the Vx voltage. Okay. Now, if this is the Vx voltage, we know that in the case of non-ideal op amp, output is what? A time V positive minus V negative. What is A? That is 1000 by S. So V naught is equal to 1000 by S. V positive is 0 and V negative is Vx. So minus 1000 by S and Vx. What is Vx? This value. 10 times Vi by 11 plus V naught by 11. That is also equal to the V naught. If I take the V naught term together, so V naught, it is 1 plus this minus becomes plus 1000 S into 1 by 11. That is equal to minus 1000 by S into 10 VI by 11. So V naught is equal to minus 1000 by S into 10 by 11 divided by 1 plus 1000 by S into 1 by 11. Now if you see that V naught upon Vi is nothing but A naught upon 1 plus S upon omega naught. So in the denominator S is numerator part. Okay. But here you can see in the denominator S is also in denominator. So what should I do? I just take a common all this particular thing. So minus 1000 by S into 10 by 11. 1 upon in the denominator when I take a common, so it becomes 1 and it becomes a S into 11 by 1000. Denominator is 1000 S into 1 by 11. So 1000 and 1000 cancel out, S is S cancel out, 11 and 11 cancel out. So what is V naught upon Vi into Vi?
Minus 10,000 by 11s plus
Minus 10 divided by 1 plus S in divided by 1000 by 11. 1000 and 1000 this will be cancel out. So only 10 is remaining. Okay. S and S cancel out, 11 and 11 cancel out. Okay. Now if I compare this equation with this one, so you can see the A naught is 10 and omega naught is 1000 by 11 because this particular term is the omega naught. This is omega naught and this is A naught. And this sign is because of a inverted. Okay. So you can see in the case of non-inverting amplifier, sorry, non-ideal amplifier, V naught upon Vi is simply minus 10. But in the case of non-ideal amplifier, this is the minus 10 upon 1 plus S upon 1000 divided by 11. So this particularly output upon input ratio, or basically the voltage gain is dependent on frequency. Okay, that is a function of frequency. That one is function of frequency. Whereas that is not a function of frequency. Okay, or if I relate this one into the this particularly, so I can write as a V naught upon Vi is equal to minus 10 upon 1 plus S upon infinity, because S upon infinity is 0. Okay, and this one 1 plus 0 become 1, so it is equal to the minus 10. So I can write as a minus 10 as a minus 10 upon 1 plus S upon infinity. So you can see the bandwidth is what? Infinite. Bandwidth is infinite for ideal. Clear? Any doubt?
No, sir.
Okay. Now, if you see that, if you are taking two particularly with the same value. So our transfer function is minus 1 upon omega n by 2. This is omega n by s. Okay, and if we are not using any particular resistance, Vi V naught, so V naught upon Vi is minus 1 upon 1 plus s upon omega naught. This is omega naught by s. Okay, so if I say that this is the Kr, if I say that this is the Kr, so the value is minus K upon 1 plus s upon omega n divided by K plus 1. Okay, so you can compare this one with the previous diagram. So if K value is 10, so the response is minus 10 upon 1 plus s upon omega n or 1000 divided by K plus 1. Okay, now in this case K R is 0. So we can say K is 0. So the particular relation is minus K upon 1 plus s upon omega n divided by 0 plus 1. So that is minus 1 upon 1 plus s upon omega n divided by 1. So the bandwidth is omega n, and here the bandwidth is omega n divided by k plus 1. If it is a r, so the bandwidth, if it is a r, not k, so the bandwidth is omega n divided by 2. Okay. So the thing is that if we are providing the Vi, that is a sinusoidal wave, and we require two waves. One is a sine wave exactly, and second is the sine wave with negative or 180-degree phase shift. Okay, so your circuit will be, you apply the Vi minus this one. So V naught is minus Vi into 1 plus S upon omega. And second, from this Vi, you are taking V out is exactly the Vi. Okay. Why these two things is required? Because when we go into the communication part, in the communication we require two particular data. One is the in phase data and one is the quadrature phase data. That means one where the phase shift is 0 degree and one where the phase shift is 180 degree. So we can get these two data with a single circuit. Okay, with a single circuit. But now if we are going to implement with the help of this, with the operation amplifier, so what should we do? We are using the same circuit but in a non-inverted mode. So this become plus, grounded, R, okay. Now here if you see what is the V out is nothing but Vi into 1 plus S upon omega n by 2, and here also we are getting the S upon omega n by 2. Okay, so both signal is a half bandwidth and the polarities are just 180 degrees. Okay, so when we are going to implement a particularly communication block set, so where we require a 180 phase shift, so we use this circuit for a 180-degree phase shift as well as the bandwidth will be high, half. Any doubt? Yes, any doubt? If you want to ask any question related to the week 7, you can ask. If no doubt, then can we stop here? Okay. We will start week 7. So that is the main concept related to the week 7. Except this one, I think there are third order filters also there. But we already see that if we go with the higher order, our system should be unstable. For the stability only, it will be dependent on the gain. How much gain you provide in the filter. Okay, so that is similar to the second order. You can solve that with the help of the second order. That is the main important things related to the week 7. So I think we stop here.